In this video, in Fundamental of Electrical Circuit series, we're going to talk about current dividers. The goal here is that if you've got a current source, that is putting out a certain amount of current, Is, and we want to make sure we want a certain amount of current to flow through this branch. So we have some specific I out in mind that we want to run through this. Let's say we maybe have an LED light we are trying to control, or a temperature we're trying to control, or whatever. How do we do that? Well, the way we could do that is add another resistor, or a controlling resistor. So let's say this is R1 and this is R2. By adjusting the value of R1 and R2, we can guarantee the voltage that the current that runs through R1. So let's take a look at how we would do that. Let's say someone gives us an Is that is equal to let's say 6 amp, and they want us to make sure that on this branch only 1 amp goes down. Okay, so that's what they've given us, and that's the goal of this process for this problem. So again, like we've done before, we look at what techniques do we know that allows us to analyze this and figure out what value of R1 should be, what value of R2 should be. KCL and KVL are really a general purpose capability tool that we have, and we always really need to look at whether these will help us or not. For this case, we take a look at it. So we can use KCL, we can use KVL. If you use KCL, it's got a couple of branches, a couple of loops or meshes that we can work on. If you want to use KCL, it might be just a little bit easier. So what we could do, we could say, okay, there is an essential node here. There's an essential node here, and we're going to call that V. And then the other node, the second node, we're going to call reference. There are two essential nodes. One is going to be reference, one is going to be just the voltage. And then we know that based on the KCL at V, we can say all the current leaving this node. So this, they told us 6 amps coming in. So that's fine. So we say, okay, 6 amp is coming in, therefore it's going to be minus 6. Remember, all the outgoing current is positive. Plus, we're going to say, okay, 1 amp was running out there. 1 amp, ugly looking one. Plus some current here which we don't know, I2, let's call it I2. I2. So I2 equal to 0, which is okay. So now we know that I2 has to be 5 amps based on this equation. So now the question is that helping us find R1 and R2 such that we get the right answer? Almost there. So the next thing we know because these two resistors are in parallel with each other, we know whatever the voltage is across R1 has to be equal to the voltage in R2. So V of R1 has to be equal to V of R2. So okay, what's V of R1? V of R1 is going to be I0 times R1. That has to be equal to I2 times R2. All right. So do I know this information? I know most of the information, which is, I know I0 is 1, so that's just going to be R1. And I know I2 is 5, so this is going to be 5 R2. If you watch the voltage divider video, you're almost in the same situation where we have lots of choices to make. And the choices are such, whatever you pick, you can pick R2 for whatever you want. You can pick it to be 1 ohm, that means R1 has to be 5 ohm. And if you do that, you're gonna make sure you're guaranteeing that I0 is equal to 1 amp. This is called the current divider. Much like current voltage divider and current divider, this is the simplest form, but they could come with all variety of sizes and things like that. But that's kind of the basic process. You are given a source as to guarantee that a certain amount of current goes through a branch. You will use a controlling resistor to control what it goes in. There are books that have formulas. Do not memorize the formula. This is a very simple KCL process or a KVL process, and you can get the answer simply. Now, the only other thing you got to remember for these kind of current divider, there are infinite number of solutions, and by picking one resistor, that defines what the other resistor is. And that gets us to the end of this video.